Okay, so good afternoon to all. Let me share my screen. Okay, so in last lab session, we performed the experiment number 5. Actually, we are performing the experiment number 5 in two sections. First, we are performing the experiment about the half adder and the full adder circuit. And in last lab, we are performing the experiment about the half subtractor and the full subtractor circuit. Now, actual application of the adder is to add two binary numbers. Again, in adder, we have two types. Let's say half adder and full adder. So half adder is used to add 2 bits, while as full adder is used to add 3 binary bits. Sorry. So same way, there is another circuit which is known as the subtractor. So my subtractor circuit is known as it is used to subtract two binary numbers. Okay, the same way as we have the circuit of the adder, the another application of the, you can say, combinational circuit is the subtractor. So again, the subtractor circuit is having two types. One is known as the half subtractor, and another one is known as the full subtractor circuit. This one. Okay. So we already performed this experiment. Again, half subtractor is used to subtract two binary numbers, and the full subtractor is used to subtract three binary numbers, in which we have three numbers. You can say the A, B, and the third bit is borrow in, B in. Same way in full adder, we have three inputs. Let's say A, B, and carry in. Okay. So in each and every this combinational circuit having a two outputs. Either it will be a half adder or a full adder or a half subtractor or a full subtractor. It having a two outputs. Okay. In adder, we have the two output which is known as the sum and carry. And in subtractor, we have the two output which is known as the difference and borrow. So this experiment we already performed. Okay. So now we have to perform the experiment number 6, which is about the code converter. Okay. So here we are learn to convert various code converter. Okay, we are performing the experiment about the various code converters. You are aware about that we can convert our binary number into gray code into binary. Again, we can convert our BCD into XSP or binary into XSP. So, and the decimal into BCD. So we have actually different codes available. We already learned about the BCD code, XS3 code, gray code, then error detecting and error correcting code. Okay, so that we already learn about. Okay, 1 minute. So today we are performing the experiment about the code converter. So we are first converting binary to gray code and gray to binary. So can anyone tell me which gate is used for the conversion of binary to gray and gray to binary in a chat session? Again, I am repeating my question.
XOR.
Very good view. So it is exclusive OR
Sir,
gate. So generally we
X4.
are using the X. Yes, yes. Okay. I'm getting the
સર,
response in the chat also.
એક વસ્તુ
Yes.
પૂછવી હતી. આપણે એક્સપેરિમેન્ટ 2 અને 3 પછી કરશું?
બાકી છે સી બેચ ને
હા સર, અમારે બાકી છે.
આમાં એટલી વાર લેબ મર્જ થઈ ને કઈ ખબર જ નથી કયો બાકી છે કયો નથી એવું.
એમાં સર અમારે કમ્બાઇન્ડ વચ્ચે 2 આવી ગઈ ને તો આપણે 1 પછી ડાયરેક્ટ 4 કરી દીધું હતું. 2 ને 3 પેન્ડિંગ રહી ગયા હતા.
ઓકે. Let me. So let's perform today experiment number 2 and 3 both. Okay. So first we are performing experiment number 2. So again, let me show you. Then we are moving to the next session. We will see about the experiment number 6. Okay. So now the experiment number 2 is about the configure the diodes and the transistor as the logic gates. Okay. Now again, let me tell you. So generally, suppose we already learned about the AND gate, OR gate, NOR, exclusive OR, and exclusive NOR gate. Okay. But actually, how these gates are made? Can anyone tell me? Okay, what is inside that particular gate? Suppose for AND gate, what is inside that in that circuit that gives me only when I have both the input is one, then and then it will give me the output one.
સર ડાયોડ ટ્રાન્ઝિસ્ટર અલગ અલગ મેથડ પ્રમાણે અલગ અલગ રીતે બનાવી શકીએ ગેટને.
Yes, yes,
DDL, TTL.
yes. So that circuit we already learn in the basic electronics. Generally, that is known as the combinational circuit. So we have different combinational circuits available. Like RTL is the basic. RTL is the basic combinational circuit, which is known as the resistor transistor logic. Then we have diode transistor logic. We have transistor logic. We have CMOS also. Okay, complementary metal oxide semiconductor, and we have ECL also, emitter coupled logic. So we have different types of logic circuits are there, and again that logic circuits are made by the simply diodes and transistor only. Okay, that is made by the diode and transistor only. So these all gates are actually made by the diodes and the transistor. So today we have to learn about the all the logic gates, which is actually made by the diodes and the transistor. Okay. So first of all, we learn about its theory, and then we will perform this experiment. Actually, this experiment we cannot perform in a Delphi. Okay, we have to perform that experiment in a multi-sim. So I think all of you are aware about that multi-sim because in basic electronics we are using this tool multi-sim live. Okay, so in multi-sim live we are performing the all the basic electronics experiment. So today we are performing this experiment also in the multi-sim, which is experiment number 2. Okay, so again this link is already there, which is the again the virtual lab link of the IIT Bombay. So let me share this link with all of you in a chat. So you can click on that link. So the new tab will be open. So let me open that. Okay. So this is our experiment number 2 actually, which is the realization or you can say the implementation of basic logic gates Like we have seven logic gates, and or not, NAND node, exclusive or, and exclusive node. By using the, you can say, one minute, by using the diodes and transistor. Okay, 1 minute. There are some network issues. Actually, in that link, that link, it's of the experiment number 3. Now, this is actually our experiment. Okay, so let me open it and let me share the link. Okay, so if you open this link, uh, this will be open. Okay, if you click on that link, this okay. So now let me directly go to the theory. So actually, we are implementing this basic logic gates. Let me increase. Yes. Okay. So actually, the logic gates, you can say it is the basic building block of any digital system. Okay. The basic logic gates are the basic building block of any logic circuit. But actually, how they are made? So these logic gates are nothing but it is the electronic circuit. Okay, which having more than one input and only one output. So you can see here for NOT gate we have only one input. For all other gates like AND gate or NAND, NOR, exclusive NOR, we have two inputs. So it having one or more than one input. Sometimes we have three input AND gate also. You can see we are already used that in a Dell sim. But all the logic gates having only one output. Okay, you are not having, we do not have any logic gates. We don't have any logic gate which having a more than one output. So input may be in anything. Either it will be one, two, three, four input gates also available in the market. Okay, but four input gate also having only one output. So that's the logic gate. It is made by the actually electronic circuit, and electronic circuit is again nothing but it is the electronics component. Like we are using the diodes and transistor mainly, and MOSFET also, because nowadays if you are taking any ICs of the logic gates, it is made by the MOSFET. Okay, so we are using the CMOS circuit and ECL circuit for that. So these are the seven basic logic gates, which is known as the AND or NOT, NAND NOT, exclusive or an exclusive NOR gate. Okay, so this we already aware about that. This is the you can say the symbol or the logic diagram of the AND gate, which having a two input and one output, and this is its equation, which is multiplication, means y is equal to a into b, and this is the truth table of the logic gate AND gate. So all the inputs, when all the inputs of the AND gate is high, then and then its output will be high. Okay, for any other combination, its output is always remains zero. So you can see here for 0 0 also it is 0, 0 1 0, 1 0 0. For when both the inputs are high, 1 1, then and then we have the output 1. Now actually how these logic gates are made, okay, this AND gate. So we are using the RTL logic, which is the resistor transistor logic, to make this AND gate. To make this AND gate. So now you can see here. Okay. Now which configuration, which transistor it is? Can anyone tell me? Let me zoom it out more. Okay. See, you have the types of transistor like NPN and PNP. So which type of transistor here we have? Am I audible? Which type of transistor this one? NPN or PNP, T1 and T2? Either you give me the response in chat also. Okay, so I'm getting the response from the Deepak. It
NPN.
is NPN. Yes, it's
NPN, sir.
NPN. Yes, yes, very good. So it is NPN transistor. Okay, and here you can see this is my input. Okay, so when my input is 0, what that means? Here we are not giving any pulses, and when my input is 1, what that means? We are giving the pulse to the gate. So you are aware about the transistor. You all learn about the transistor. Okay, you already learn about the transistor in the basic electronics subject, second step. So when we are not giving any signal to this, okay, so gate does not get any signal. So this transistor T1 is working as an off switch. So now you can say when my both the inputs 0 0, so my A and B both are 0, so no current. So my transistor T1 is also off and my transistor T2 is also off, so no current is passing through the output. So that's why my output is 0. So for 0 0 it is 0. Let's say my B is 0, A 1. So as I am giving the input to the A, so transistor T1 is on. So current is passing through the transistor T1, but again I am not giving any signal to the transistor T2. So it will be working as an open switch or switch off, you can say. So again, there is no path of the current to passing through the output. So for 0 1 also it is 0. And let's say for 1 0, again my input B1, A0. So my transistor T1 is off, T2 is on, so no current is passing through this T1 because it is off. But when you are giving both the input 1 1, when you are giving both the input 1 1, so your transistor T1 is also on, transistor T2 is also on, so current is passing through the transistor T1 to the T2 and to the output. So this is the actually circuit of the AND gate, okay, which is made by the RTL logic, which is made by the RTL logic, resistor transistor logic. Anyone having any doubt in this? ओके कब ये ऑन होगा? जब हम गेट पल्स देंगे तभी ट्रांजिस्टर T1 या तो T2 ऑन होगा. ओके बट जब दोनों ऑन होंगे तभी we are getting the output in the output, otherwise we are not getting any output and my output remains 0. So this is first gate, AND gate. Now second, OR gate. So again you can say this is the OR gate. The logic symbol of the OR gate is equation y is equal to a plus b, and again we have the equation which is, what's the truth table of the OR gate says? When all the input, again I'm repeating, when all the input of the OR gate is 0, then and then its output will be 0. For any other combination, its output always remain 1. So you can say for 0 0 only it is 0, for 0 1 also it is 1, for 1 0 also it is 1, and for 1 1 also it is 1. Okay. So again, we can implement the OR gate by using two logic. You can implement the OR gate by using DRL logic also, which is my diode resistor logic, and you can also implement it by TTL, which is by transistor logic. Okay, but here we are using the diode resistor logic. You can see here. Let me show you. Yes, this one. So again, here we are using the diodes instead of the transistor, and that's why it is known as the diode resistor logic. Okay, that's why it is known as the diode resistor logic. So now again, you can see I am connecting my input here, A and at B. Okay, so 1 means we are giving the positive terminal plus 5 here, and 0 means we are connecting this terminal with a ground. So again, diode having a two terminal, which is known as the anode and cathode. So when you are giving the input to the A, let's say this is my diode D1. For A it is D1, and for B it is D2. So suppose the first input both are 0 0. As both are 0 0, my diode D1 as well as my diode D2 both are reverse bias. Both are reverse bias. So no current is passing through the diode, and hence we are not getting any output. My output will be remain 0. Now let's say I'm giving the input A0 B1. For A0, my diode D1 becomes reverse bias, and for B is equal to 1, my diode D2 is become forward bias. So now no current is passing through the diode D1, but then also current is passing through the diode D2 and to the output. So we are getting the output 1. So for 0 1 we are getting the output. Let's say my A1 B0. So A1 B0, so diode D1 becomes forward bias, D2 becomes reverse bias. So current is passing through the diode D1, and to the output my diode D2 is working as a reverse bias only. And both are 1, so both 1. Again, both the current, both diode are become a forward bias, so current is passing through the diode and to the output. Okay, so this is the implementation of OR gate by using the DRL logic, which is diode resistor logic. Now third gate is about the NOT gate. So now you can see this is the logic diagram of the NOT gate. NOT gate is also known as the inverter gate. Okay, it is also known as the inverter gate. Why? Because when you are giving the input 1, it will give the output 0, and when you are giving the input 0, it will give the output 1. Okay, so again we can implement the NOR gate by using a single transistor. So again we are using the RTL logic. Again we are using the RTL logic. Now let's see how it will be work. Suppose you are giving the input 0 here, A0. So my transistor Q1 will be off. My transistor Q1 will be off. So all the current is passing through the R1 and to the output. So hence my output is 1. Hence my output is become 1. So here I am giving input 0. Here I am getting 1. So it is inverted. Now suppose if you are giving the input 1 here. So as we are giving the input 1, your transistor Q1 becomes on. So all the current is passing through the transistor Q1 and to the ground. No current is passing through the output, and hence my output becomes 0. So when your input is 0, your output is 1. Where your input is 1, your output is 0. You can see here. Okay. Sorry. So this is the RTL logic. So anyone having any doubt in this? Okay, so let's move ahead. Now, next one is about the NAND gate. So, NAND gate is nothing but you can say it is AND gate followed by the NOT gate. So, what we are doing, you have the AND gate and you are connecting the output of the AND gate to the NOT gate. So, finally, the output of the NOT gate which you are getting, it is known as the NAND gate. So, you can see here, NAND gate, it is also known as the NOT AND gate. So, the NOT gate, which is ahead of the AND gate, it is denoted by the symbol which is known as the circle, or it is also known as the bubble. Okay, so we are implementing a bubble that becomes a NAND gate. So now the output of the NAND gate, which is opposite to the AND gate, totally opposite to the AND gate. Now let me tell you again about the AND gate. What's about the AND gate? When all the inputs of the AND gate is low, or or sorry, when all the inputs of the AND gate is 1, or you can say high, then and then we are getting the output 1. Then and then we are getting the output 1. For all the other inputs, we are getting output 0. So here it is reverse. When all the inputs of the NAND gate, when all the inputs of the NAND gate is high, when all the inputs of the NAND gate is high, then we are getting the output 0. Okay, then we are getting the output 0. For all other combination, we are getting the output 1 only. Okay, we are getting the output 1 only. You can see easily here. 1 minute. Yes. Hmm. When my input is 0 0, then my output is 1 for 0 1. Again my output is 1 for 1 0. Again my output is 1, and for 1 1. Now for 1 1 my output becomes 0. Okay, for 1 1 it is 0. So again, the same circuit, you can see the difference between the RTL logic of the NAND gate and NOR gate. Let me tell you again. I will show you the RTL logic of AND gate. In RTL logic of AND gate, we are taking the output from this point, from the T2. While is for NAND gate, we are taking the output before T1. Let me show you the AND gate circuit. See, for AND gate, we are taking before T2. For NAND, we are taking after T2. And for NAND gate, we are taking before the T1. See the difference between the circuit. Just we are changing the output position. Okay. 1 minute. Yes. So now you can see here actually, let's say my input is 0 0. Okay, so for 0 0, both these transistor T1 and T2 is off. Okay, for 0 0, for 0 0, both these transistor T1 and T2 becomes off. So current is passing directly to the output. So for 0 0, my output is 1. Let's say my input, let's say my transistor T1 off, T2 on, so 0 1. So again, no current will pass through the transistor T1. So again for 0 1, I am getting 1. For 1 0, again I am getting 1. But let's say both the inputs are 1 1. As both the inputs are 1 1, okay, transistor T1 is also on and transistor T2 is also on. So both the transistor is in on condition. Okay, it is in on condition. So now current is passing through this transistor T1 to the T2 and the ground. No current is passing through the output. Hence my output becomes 0. Hence my output becomes 0. So that is the working of NAND gate by using the RTL logic. NAND gate by using the RTL logic. Now next one is NOR gate. Okay. So again, NOR gate is nothing but it is known as the not OR gate, like not AND gate. Same way. So again, if you are connecting the output of the OR gate to the NOT gate, it becomes a NOR gate. Okay. And the implementation of NOT gate we are indicating by using this bubble. So again, the truth table of the NOR gate, it is absolutely reverse. Then the OR gate, for OR gate, only 0 0 we are getting 0. For 0 1 also we are getting 1. For 1 0 also we are getting 1. And for 1 odd also we are getting 1. But here, now, for NOR gate, only when my both the input is low, so 0 0, then and then I am getting the output 1. Then and then I am getting the output 1. For 0 1, for 1 0, and for 1 1. For all other combination, I am getting always output 0. Always output 0. Okay. So again, let me show you the circuit. So this is the implementation of a NOR gate by using the RTL logic, which is resistor transistor logic. Okay. So let me show you how it will be work. Okay, so now let's say, see, suppose my input A is 0 and B is 0. Okay, A is 0 and B is 0. So for 0 0, my transistor T1 is also off and my transistor T2 is also off. So all the current is passing through the output. Okay, now let's say only my transistor T1 is on. So current is passing through this transistor T1, through this, and to the ground, and to the ground. Okay. So then again for 0 1 I am not getting the output. Let's say my transistor T2 is only on. So current is passing through this part to the T2 only and again to the ground. Let's say it is both on. So all the current is passing to the transistor T1 and T2 and the ground. So when both the transistor is off, when both the transistor is off, then and then we are getting the output 1 or we are getting the output. For all others combination, we are always getting output 0. For all other combination, we are always getting output 0. So here, for 0, 0 only it is 1 and for all others it is 0. Next one is about the exclusive OR gate. It is the special types of gate. It is also known as the dissimilarity gate. What that means, when both the inputs are different to each other, then and then it will give the output 1. So for 0, 0 and for 1, 1, it gives the output 0. And for 0, 1 and 1, 0, it gives the output 1. But its circuits, it's somewhat very much difficult. Again, we are using the RTL logic only. But you can see here we required actually uh, 6 transistor. Okay, so it is somewhat difficult to implement. Now next one, it's about the exclusive NOR. So it is again exclusive OR and NOT gate. So it is also known as the similar gate. For 0, 0 only it gives the output 1 and for 1, 1 also it is gives the output 1. For 0, 1 and for 1, 0 it gives the output 0. So you can see again we are using 1, this is 2, 3, 4, 5, 6 and 8. Total 8 logic gates we required with this amount of resistors. We can implement this. Okay, any one, this, all the above circuit, exclusive or also we can implement. But in exclusive OR, we require the 6 transistors, while in exclusive NOR, we require the 8 transistors. Circuit is already given, you have to connect like that only, so you can implement that. Okay, so this is all about the logic gates. Anyone having any doubt in this? Of any logic gate, anyone having any doubt? I'm waiting for your response, student. Anyone having any doubt?
No, sir.
Okay. So now let me go for the pre-test. You have to give me the answer, okay, in a chat. Okay. The first question is the electronic circuit that operates on one or more input signal to produce the standard output. It is known as a series circuit, parallel circuit, logic signal, or logic gate. A, B, C, or D. What is the answer? Okay, I'm getting from answer from Yom. What about others? Okay, I required the response from everyone. Okay, what is logic, Viraj? We have two options for logic. Either it is logic signal or it is logic gate. So C or D, just write down A, B, C, D. No need to write down more things. Okay, I'm getting the response from the Krishna, Raj, Hers. Okay. So actually the all give me the answer. It is D, which is logic gate. Now second question. Which gate gives the output as a 1 only if all the input signals are 1? Okay. So again, you have option A, B, C, D. So Hers, Viraj, Krishna, Manav, they are giving the answer. Let's say it is A. Okay. So Vyom and Raj. So let me click on A. Now, what is the Boolean expression for OR gate? Okay. So I'm getting the response from the Vyom, Hers, Krishna. Okay. So all are giving that it's C. Very good. Now the gate which is used to reverse the output. Yes, so I'm getting the response from the Vyom, Hers, Raj, Manav, Krishna. Okay, very good. It's a note. Last one. Which of the following gives zero when both of its inputs are one? Okay, let me select the NAND. Actually, here the exclusive OR gate is also the correct answer. Okay, why? Because you can see here the question is which of the following gate will give zero when both of its input are one. So if you remember the truth table of exclusive OR gate for 0 0 and for 1 1 also it is giving 0 only. So here instead of exclusive OR they have to ask exclusive NOR because in the same question we have two correct answers. Okay, NAND is also correct. If you click exclusive OR they are giving you the says that your answer is wrong. Okay, but here there are I think the typing mistake. Instead of exclusive OR they have to write down here exclusive NOR. Okay, so now let's move ahead. So we have to move for the simulation. So all the logic gates are here, 7. Let me just show you how you have to perform the experiment. So I'm implementing the OR gate for all other input. For all other gates, you have to perform the experiment. Okay. So again, we have two simulators. You can see here. So first of all, we have to double click on the battery. Then it is written like that connected. So let me double click. So you can see here it is written connected. Now if I switch on this conductor becomes green. Now you can see. Now this is my inputs actually for transistor T1 and transistor T2, and that we will also implement by using multi-sim. Okay. So first let me show you here, then I will implement in a multi-sim also. So for 0 0 you can see my output is 0. For 0 1 also my output is 0. For 1 0 again my output is 0. But for 1 1 you can see my output is 1. For 1 1 I am getting the output 1. Okay. So anyone having any doubt in this? Okay. So let me show you how we can implement this circuit by using the multi-sim live. Okay. So let's see that. I think all of you having a account in this because we are using this in a basic electronics only. 1 minute. Okay, so let me create the circuit. Then you have to implement for the other. Okay. So now suppose I have to implement this circuit. So I require two transistor, one battery, three switches. This switch is not compulsory. You can use this switch only. So let me make a circuit. I require the two transistor, which is NPN. So I am taking the two transistors. Let's say this is one. Let me make a copy. And this one is my second. Then I have to connect one lamp load. So I'm connecting a lamp also. I'm putting the lamp, let's say, uh, here. Okay. Then we required two switches and resistors and the battery source. So let me take the source, which is my DC voltage source. Okay, let me take this one. Okay, then I require two switches. um, and the resistor also. We have enough space here. Now let's connect the circuit. Okay, so this is the circuit you can see here. Okay, same circuit which is here that I am implementing. Just I am not considering this switch. Okay, I am not using this switch. Another, otherwise, I will implementing the same circuit here. Now, let's change the value of resistance too much high. Let me take only 5 ohm. Okay, and let me take this voltage source as a 25, or let's say only 20 volt. Okay, okay. So now let's start simulating. So let me. We have to see the lamp only. Okay, so you can see the lamp is off for 0 0. For 0 1 again it is 0. For 1 minute. Mm, okay, there is some mistake. Let me show you what mistake I has made.
સર ત્યાં ગ્રાઉન્ડિંગ કરવાનું હશે એવું હશે કદાચ.
Maybe
હમ.
કંઈક mistake છે. It's getting some a minor voltage because when it both are 1 1, you can see the glow of lamp, but it must be off at this also. It's getting some very less amount of voltage. Let me change its value to. They are also not giving you the actual value of this. Okay, what is the main problem? We are using the similar battery or single battery too. So when it is on, the current is passing through this switch to the transistor and to the bulb also. So bulb getting the minor voltage. But this is actually the circuit. If you are giving the source, both the source to the different supply, okay, then this problem will be neglected. Let me show you that also. So as for both 1 1, it will give the 1. Okay, so let me simulate that circuit first.
સર બે જી આપણે ઇનપુટ છે ને બેના અલગ અલગ સોર્સ છે ને?
હા, બેના સોર્સ અલગ અલગ અત્યારના.
તો આમાં એસી સોર્સ નહીં લગાવવું પડે છે?
હે?
આમાં એસી સોર્સ નહીં લાગે?
ના, એસી ક્યાંથી લાગે? ડીસી જ આવશે. વન મિનિટ. Do not leave the meeting, okay? Lamp is blowout because I'm giving the very much high voltage. You can see here. Let me take is as a 12 only. Okay, so now you can see here I am implementing the circuit. Okay, see, generally when we are giving the transistor as the input, we are giving the different supply. So I want to give only a gate pulse only. So when I'm not giving any gate pulse to the transistor T1, so it will be off. So no current is passing through the transistor. So no current is passing through the load also. So lamp also. For 0 0 also lamp is again. For 0 0 also it is 0. For 0 1 also it is 0. For 1 0 also it is 0. But when your both the transistor on, then and then your lamp will be glow. You can see. And if you want to make it brighter, you have to reduce the resistance which is connected in series with the lamp. So this is the implementation of AND gate. This is the implementation of AND gate in a multi-sim live. So you can see here, and if anyone having any doubt, you can ask me. Anyone having any doubt? I'm waiting for your response. Anyone having any doubt? Okay, Viraj. So now same way you can implement each and every circuit. So this is only about the AND gate. If you want to implement the NAND gate, you can easily implement the NAND gate also. Now just you have to change the resistors. Let me show you here. Again, let me go to the simulation. Let me show you the NAND gate. And you can also implement the OR, NOR, NOT gate. Any gate you can implement by using this RTL logic in a multi-sim live. So instead of connecting the load here, if I am, let me stop this, and if I am delete this one, and now I am connecting my load, let's say, sorry, here, and let me run. Okay, so sorry, because I am connecting directly parallel the lamp load. Let me disconnect it. We have to select the perfect value of this resistance. Then current will be passing through the transistor T1 to the T2 and the ground. We have to check the internal resistance also for the transistor. Okay, so that's how we can implement each and every gate. Okay, so now you have to, I already show you how AND gate OR gate is working. Now you have to implement on simulate these all the gates. So start simulating. Yes, Vyom, I'm not getting your question. How Vyom?
સર
Well, how
આમાં
we
તમે કીધું કે આપણે વેલ્યુ એની સિલેક્ટ કરીએ તો જ આમાં સિમ્યુલેશનમાં બતાવશે સરખું એ વેલ્યુ કેમ
so
ખબર
which
પડે?
yes, simply it is also available. See, we do not have more time, otherwise I will implement each and every circuit. But see, and get by using RTL. You can use this value. See, it is already available. 4K, 4K, 2K, 470, 470, 3.6. All the voltage source and the value they are giving here. You can implement like this also. Okay, 10K, 10K. Then from here we are getting the output. So you can connect the output means your lamp between V out and the ground. This will be 4.7K and VCC we have to give 6 volt. So we have a different, you can use any values of this. Okay. We have numbers of circuit. You can see this is the another. It's not compulsory to always connect the lamp load. You can measure voltage here. So if your voltage, you are getting the voltage, what that means your output is 1. And if you are not getting the voltage or voltage 0, what that means your output is 0. So it's not compulsory to connect lamp load each and every time. Okay. Okay, so that's all from my side. If anyone having any doubt, you can ask me a question. Otherwise, we will end this session. Okay, and you have to implement each and every circuit in a multi-sim because you already
સર
work on
બે
the
ત્રણ ડાઉટ
multi-sim.
છે.
બોલો Vyom.
સર પેલો ડાઉટ કે આના સબમિશન હવે તો મિડ પછી જ રાખશો ને ઓલું તમે ડેટ એક્સટેન્ડ કોક ઓલા મેડમ ને કઈ કરાવવાના હતા.
હા એ હજી કર્યું નથી ને એટલે પછી જ રાખશું.
ઓકે. અને
બાકી
બીજું કે
જેટલા
સર આ આપણે
થઈ ગયા છે
હમ
જેની ડેટ ઓપન છે એ તો અપલોડ કરી જ દેજો. જેમ કે એક્સપેરિમેન્ટ નંબર 5 હજી ઓપન હશે તો એક્સપેરિમેન્ટ નંબર 5 તમારે અપલોડ કરી દેવાનું. કારણ કે એ તો આપણે પરફોર્મ
એવું
કરી
છે
દીધો
હા.
બધી બેચમાં. હા તો એ તો
ઓકે
કરી જ
આ
દેવાનું ને
કરી
પછી એક
નાખ
સાથે શું કામ. હા
સર હજી એક કે આનું આપણે મિડમાં પૂછાશે લેબ સેશન્સ નું.
ના લેબ સેશન નું આ કઈ નહી.
કેમ કે ઓલું અસાઈનમેન્ટમાં ક્વેશ્ચન હતું ને તો મને લાગ્યું કે એ આપણે થિયરી એની ભણવાની હશે એમાં પેપર માટે.
શું શું ક્વેશ્ચન હતો અસાઇનમેન્ટમાં?
સિગ્નલ વાળો નતો.
એક જ મિનિટ જોવું પડશે.
સર ઓલો એનાલોગ ને ડિજિટલ સિગ્નલ વાળો.
ફર્સ્ટ ક્વેશ્ચન.
આ તો જૂનું હશે. ના
બે
આ નહી આવે
દિવસ
કે ડિફાઈન. ના એ નહી આવે.
ઓકે ઓકે.
જો એનાલોગ એન્ડ ડિજિટલ સિગ્નલ એવું કે
તો
નહીં.
સર
સિલેબસ
બોલો.
શું રહેશે આપણો?
હા તો સર 30 માર્કમાં ખાલી કન્વર્ઝન જ પૂછાશે.
હાલના કન્વર્ઝન ક્યાં છે એટલે ઘણું કેટલું ભણ્યા બરોબર બધા કન્વર્ઝન ભણાઈ ગયું.
હા
ઓકે બાયનરી ટુ ગ્રે ગ્રે ટુ બાયનરી પછી
હા
એડિશન મલ્ટીપ્લિકેશન સબટ્રેક્શન
હમ
ડિવિઝન એ બધું ન ભણ્યા. નાઇન્થ કોમ્પ્લિમેન્ટ ટેન્થ કોમ્પ્લિમેન્ટ
હા
વન્સ કોમ્પ્લિમેન્ટ ટુસ કોમ્પ્લિમેન્ટ
હા એટલે
કોડ બધા
ટૂંકમાં
ભણી ગયા. કોડ
એટલે સર
કોડ બધા
ટૂંકમાં
કમ્પ્લીટ થઈ ગયા.
હા હા ટૂંકમાં થિયરી જેવું
થિયરીમાં
કઈ.
ગેટ આવશે. ના ગેટ
હા
આવશે ને
હા
ગેટ
એટલે
સિલેબસમાં જ છે.
બરોબર
ઓકે
સમજાય.
ક્યાંથી છે તમારી મિત છે?
20.
મંડે છે સર.
નેક્સ્ટ મંડે ઓકે. ઓલ ધ લોજિક ગેટ્સ અને ડીએફ નું 24 ના છે એ કઈ વાંધો નહીં મિડ સેમ તો 20 ના છે ને.
સર આપણું સિલેબસમાં એક જ ચેપ્ટર છે ને ડીએફ માટે તો.
ના સેકન્ડ યુનિટમાંથી છે ને. અ,
એ ઓલું એક આપી દેજો
એક
ને અમને સિલેબસ નું ઓલું પીડીએફ કે કઈક.
હા ભલે ભલે હું અપલોડ કરી દઈશ.
ઓકે સર.
ઓકે કાલે મે બી આપણો એક લેક્ચર કેન્સલ થશે ને 11:10 થી 12:10.
હા ઓલું
હા
છે
સર
વેબિનાર છે
વેબિનાર
એના
છે.
માટે થશે કદાચ.
તો હું લઈ લઈશ ચાલો ને પાછો એક લેક્ચર. હા અટેન્ડન્સ રાખી દો ચેટમાં. ઓકે કાલે જયારે લેક્ચર લઈશ ને ત્યારે તમને આખો સિલેબસ દેખાડી દઈશ. કાલ તો 99% વી ઓકે ઓફલાઈન ક્લાસીસ તો કાલથી મે બી ચાલુ થઈ જ જશે પાછું. એટલે કાલે ક્લાસમાં બી દઈ દઈશ ને જેટલા ઓનલાઈન હશે એ બધાને સિલેબસ આપણે મિડ વન નો કહી દેશું. ઓકે હા એટલે હું બીજો લઈ લઈશ કોઈનો બી લેક્ચર જેને સિલેબસ પતી ગયો છે ને મિડ નો એમનો. Okay, so if you already written your number, if you want to leave, you can leave the session. Thank you.